So we've got this concept of wind, and wind is the movement of air caused by unequal pressures, which is caused by unequal temperatures. And most of the time we're talking about winds like on a very large scale, like a different air mass pushes into the location that we're at. But wind can also be very small scale or very localized movement of air, because you can have locally different temperatures between two places that are very close to one another. Take this particular example. This parking lot back here is black, and it's been sitting in this nice hot sun, and the air over this parking lot is very hot, so it is rising. That's a little area of low pressure. Well, if we walk a few feet this way though, now right here I'm on the grass, and the air over this grass isn't nearly as hot because the grass stays cooler. So right here I've got a little bit cooler air, maybe where air is more likely to be sinking because this grounder is cooler than that ground. So here I'm going to have a little bit higher pressure, there I'm going to have lower pressure. So the air over the grass is going to move towards the parking lot. Well, that movement of air is what wind is. So this is an example of what we call small scale or very localized movement of air, and it's because we have slightly different temperatures right there than we have right here. So let's look at some examples of these small scale localized winds. Okay, so our last presentation on the wind unit is going to be what we call small scale winds. Well, what does that mean? Well, first of all, let's talk about what causes wind. Just to refresh our memory, that's the difference in pressure. Well, what causes differences in pressure? Differences in temperatures. So what causes differences in temperatures? Well, that's a lot of things. Different elevation, is there water around, a new air mass coming in, where the jet stream is flowing, things like different colors. Something's white versus dark, going to have a different temperature. Plants and trees affect whether or not the temperatures are high or low. So all of these things help to determine what the wind's going to be. The first special example we're going to look at is what's called a land and a sea breeze. And for this, we're going to be drawing some diagrams into your notes and explaining what's going on. So let's talk about wind. Just as a reminder, remember what wind is. Wind is the movement of air. And we can see that the air is moving from over here, going that direction. Now what causes wind? Once again, a reminder. Wind goes from a higher pressure where there's more air over here, and it's pushing towards the area where there is less air pushing back. So the high pressure air is going to push that way into the low pressure. Now what causes high and low pressure? Remember, the high and low pressure are caused by differences in temperature. Hotter places tend to form low pressure because the air gets hot, and when the air gets hot, it rises. So over here, we've got the beach, and we've got the city behind it. Now all that land, all those houses, all those roads and parking lots, when it gets hit by this hot direct sunlight, the ground gets hot. So the air over all of this ground gets hot and it goes up. That means over here there is now less air because the air has gone up because hot air rises. If we turn around and we look this way, over here we have the ocean. Now remember what we know about this ocean. Water doesn't heat up and cool down as easily as land. So when the sun came out today, all of that water has not really changed temperature. So it is still fairly cool compared to this area behind us. So we've got a hot area where the air is going to rise and form low pressure. Over here, this area now is cooler, so the air is more likely sinking and building up more air down here, making a higher pressure. Well, that higher pressure pushes towards the area of low pressure, and hence we get a breeze pushing from the water where it is cooler and higher pressure towards the land where it is hotter and hence lower pressure. This is a special type of wind. It is called a sea breeze. So let's diagram a sea breeze for our notes and explain what's going on that gives us this movement of air that we call a sea breeze. Now, first of all, I'm going to draw myself a nice happy little sun here, because we know it's going to take some change of temperature to make a change in pressure to cause any kind of movement of air. Well, sea breeze means we need the sea. So I'm going to draw myself my little ocean right here, and then I'm going to draw myself a little beach. That's my beach, and there's my ocean. Now let's talk about what goes on to give us that formation of a sea breeze. Okay, first of all, we know that the air over here is going to get hot and rise because the beach or the land gets hot easier than the water. So we're going to say land gets hot, and we know hot air rises, which makes low pressure. That's exactly what happens. But the air can't go up for an infinite distance because gravity still works. So it wants to get up here and it wants to spread out. It wants to move apart. And it has a hard time moving inland because there's more land over there and more air still trying to go up over here. So what happens is our air does this. The air expands and moves out over the water. Because that's the way you can expand, and we know that hot things want to expand. Now, once it gets out over the water, and remember the water's a little cooler, so the air here over the water isn't rising, it's actually sinking. So air over the water is sinking. Now, air sinking means there's going to be more air down here, which forms high pressure. Well, now we've got an area of high pressure here and an area of low pressure here. High pressure here, low pressure here. And when we have unequal pressures, nature is going to cause things to try to equal out, and we're going to get the movement of the air from the high pressure to the low pressure. So we get wind moves from the water to the land. The water is the sea, hence we have what's called a sea breeze. Because if you were standing right here, you would feel the air coming to you from over the water or from the sea, hence the name sea breeze. This is what you need to understand, and this is the diagram that you need to have in your notes. Now let's talk about what causes the phenomenon known as a land breeze. Land breeze, now notice it's nighttime. Got the moon and the stars. It's nighttime. Well, at night, the beach cools down a lot more than the water because we know the land changes temperatures a lot more easily than the water. That means this is actually cooler than this right here. Well, over the cooler part, the air is actually going to be sinking. And you're going to get a creation of a high pressure right there because it is cooler here now than it is right here. Well, the water's still kind of warm, which means the water is going to evaporate a little bit more now, and it's actually going to be rising. Well, the rising air is going to cause us a little bit of area of lower pressure. And we know that wind always moves from high pressure to low pressure. So the air is going to move like this. Now, this air, when it rises, it's going to want to move this way, because that's the way it can expand once it rises, gets over the land, which is a little bit cooler, and it's going to sink and fall. And now we have what's called a land breeze. If you were standing here on the shore, you would feel the air moving from the land out to the water, hence the name of a land breeze. So let's look at the land sea breezes in this particular situation here. Notice I'm at the beach, I'm at the shore, but there's almost no breeze, because you can see, because there's no waves here. And that's because it's first thing in the morning. So it's been night, which means that this ground isn't very hot because it's been dark. And when the ground isn't hot, the air over the ground is not rising, which makes the air coming from the water this way and then go up and make a sea breeze. So sea breezes are weakest first thing in the morning when the ground is not hot. So here I am in the same location at about 3 o'clock in the afternoon, and you can tell by the sleeve of my shirt and the water back there behind me that we've got a lot more wind now. What's changed is that now at 3 o'clock in the afternoon, this land out here has gotten hot, sitting under the sun. Well, the hot land has air that is rising over it, creating a little bit low pressure. Well, the air over the water is still cool, so it's a little bit higher pressure. So remember that air moves from higher pressure towards low pressure. So now we've got that formation of a sea breeze. And a sea breeze is always going to be strongest when this land is the hottest. So typically late in the afternoon, like it is now, 3 or 4 o'clock.
You can see this in a daily temperature graph. You'll notice that we start off here in the morning, 5 a.m. Look at the wind. As the sun comes up, temperature gets hotter. Notice that the winds get faster. And the winds keep getting faster and faster and faster till we get to about here, 8 o'clock, where the sun goes down. So the strength of land and sea breezes is directly affected by the sun. So our first check for understanding, these are 3 questions that you should have in your notes. What causes sea breezes and land breezes along the coast? And that's where your little diagrams that we just drew come in. When is the sea breeze strongest and why? And when is the sea breeze weakest and why? If you don't have these, or you don't understand the answers, please ask before you move on. Now, there's some other examples of local small-scale winds. Think about these 2 areas here and what their temperatures would be like. This area over here is going to have a lot of rising hot air because it's a big city and cities get hot. Whereas over here, this is going to stay cool because of all the water. So here, air is a lot more likely to be sinking. So we got one place where air is rising, maybe another place right next to it where the air is sinking. Those little areas where the air is rising is called a thermal. A thermal is a small pocket of rising hot air. It's not all the air in an area, it's just one little spot. And you see it in here, that over the city, that urban heat island, where there's all those roads, buildings, concrete, the ground's going to get hot, the air's going to get hot, and the air is going to rise very easily. Well, out here in the suburbs where they have a lot more plants and trees, it's going to be cooler. So the air there is going to be sinking more than rising. So you get a thermal or a thermal updraft form over little patches where it's hotter than the area around it. Something like this here. Over here where the city is, that's going to get hot and rise. But over here we've got a bunch of water. We've got some wetlands. There the air is going to be sinking. This area to the left would be called a thermal or a thermal updraft. This field, the black part of the field is going to get hot because it's black. And that's going to make the air over the field rise. That would be an example of a thermal or a thermal updraft. Some applications of this: people that hang glide or fly around in planes that are gliders without engines on them. What they're riding are thermals, or updrafts. And they happen all over the place because all across the ground there's a bunch of different temperatures. Birds do the same thing. Birds like to save their energy. They don't want to flap their wings to stay in the air, so they'll find these little thermal updrafts and just kind of ride them up so that they don't have to flap their wings to get high up in the sky. Turbulence. If you've ever been on an airplane and feel a bumpy ride, that's what we call turbulence. This is a definition of what turbulence is. It's the violent or unsteady movement of air. But the question is, what causes it? Well, here we've got a little patch of rising warm air. Here we got another one. Here we got another one. And this plane is trying to fly. And when it hits one of these little thermals, it's going to feel a bump. It's going to go along. It's going to feel another bump. As soon as it's past that little bump, it's going to feel a little bit of a drop. So if you're in that plane, you feel the plane going up and down. It's kind of like a little speed bump for an airplane. Now, it's not hitting anything solid. It's just hitting air that is rising or pushing the plane up, and then it drops once it's through it. How do you avoid turbulence? If you go up here high enough and you get to the point where all the air is cool enough, you don't have those thermals. This is why pilots for commercial airliners especially fly above the clouds, because that's where the smoother air is. If you've ever flown on a plane, you know that turbulence is a lot bigger deal on takeoff and landings, or when you're still below the clouds. This is also why most aircraft going to most major cities don't fly over downtown, because the area over downtown has a lot of rising hot air. It makes for a very bumpy ride. This picture on the right, this here is downtown Atlanta. If you've ever flown in and out of Atlanta, you don't fly right over the middle of the city. You kind of go around downtown because the air right over downtown is rising so much because that's really hot ground because of that urban heat island. Dust devils. These are a particular type of thermal updrafts. We're going to diagram those and describe how they form.
So we're going to take a look at a special particular kind of thermal called a dust devil. Remember that a thermal is a small patch or a small column of rising hot air. Well, where does the heat come from? It always comes from the sun. So we're going to have thermals and we're going to have dust devils on nice, hot, sunny days. But there are places where thermals happen more so than others. There are places where thermals don't tend to happen, and that's where the ground is cool. I choose my ground, and it's covered with grass. And we know that grass as a plant doesn't get very hot very easily. So anywhere I'm going to have grass, it's going to be tough to have a thermal because the ground and hence the air over the ground is just not going to get that hot because plants help keep things cooler. But imagine that I had a little exposed path of dirt. It's got some loose dirt right here. Well, if the sunlight hits that dirt's going to get hot. And the air over the dirt is going to get hot. And we know that hot air does what? It rises. So we're going to have something like this going on. The air right there is going to be rising. Whereas the air over here will not be rising. But if this air is going away, and it's making a little bit of lower pressure, that means the air over the grass is actually a little bit of higher pressure. And we know that air is going to move from high pressure towards low pressure. So the cooler air is going to run in there to take the place of that air that has left. Well, that means we're going to have air moving that way and then going up. So this is a good example of a thermal. It's a little area of rising hot air, and it could happen over dirt, it could happen over a parking lot, over a building. But when it happens over dirt, especially loose dirt, something unique can happen. The dirt can be picked up with it. So you can actually see the thermal. Most of the time they're invisible, it's just air. But if the dirt is going up with the air, we'll see like a dirty wind. It looks dusty, and these are actually called dust devils. They look like little mini dirty, dusty tornadoes. Now these things actually spin, because just like water going into a bathtub, going down the drain, doesn't go straight in, it spins, partly because due to the spinning of the earth. So as this air rises, it does that. And that little twisty shape of the air makes it look kind of what we think about tornadoes. But it's not a tornado, because tornadoes come from thunderstorms, and they come from a cloud and go to the ground. This is going from the ground up. This is called a dust devil. Well, what is a dust devil? It is a thermal updraft that picks up dirt. Which means we can see it, because it's like a little, what we usually call a dirty tornado. But they're not tornadoes. It's just a moniker that is kind of stuck. They have that same swirly kind of shape. Now, some questions about these dust devils. Where would these happen? Well, they can only happen where you have a small patch of dirt that the hot air can pick up as it rises, typically next to some place that is a little bit cooler. So, for example, you get these on baseball fields a lot. Because think about a baseball field. You have a grassy outfield, maybe you have a grass infield, and you got a little dirty part like on the infield, and that part gets extra hot, and that's where the thermal will form and pick up some of that dirt. You have thermals that happen over parking lots, but they don't turn into dust devils because there's no dirt for it to pick up. You can't see it. Is the air rising over a hot parking lot? Yes, but because it doesn't have any dirt to pick up, it doesn't turn into a dust devil that you can see. When are these things going to happen? Typically, late afternoon in the summertime, because that's when the ground has gotten hot enough. You don't see dust devils in the morning because the ground hasn't gotten hot enough to make that thermal updraft yet. You typically don't see them at night because once the sun goes down, we cut off the energy for that air to rise. Where? Dusty or dirty places. We don't tend to see dust devils here in Georgia. And the reason is we have too many plants and trees. Most of our ground is covered with plants and trees, so it's hard for us to get these little dirty rising columns of air. Where would you see these things? Well, you see them a lot in the west, because in the western part of the country you have a lot more exposed dirt. You have a lot of deserts. Nevada, Arizona, Utah, places like that. You'll see West Texas. There have been times where I've been in West Texas driving, and I'm looking around and I can count about 20 dust devils at one time. So once again, a dust devil is a thermal updraft that picks up dirt and we can see it.
This is a picture of what dust devils look like, and you see it looks like a dusty, dirty little tornado. Here's a video of one that popped up on a baseball field. Notice it's a hot sunny day. Well, it's certainly a sunny day, and it's making the dirt part of the baseball field so hot that you get this hot air rising, get a thermal, and it picks up dust. That's what a dust devil is. Now here's a more extreme one. Here's one that's really gotten going fast. Now these aren't as destructive or as damaging as tornadoes, but you see this is one that happened in a parking lot near a little fruit stand, and it's picking up some of the lighter weight objects and spinning it around. Picked up like the tent and the trash and so forth. So you could go run and jump through this and it wouldn't pick you up, but you get an idea of how these things form and what they look like. Once again, we won't see these here in Georgia. So time for another check for understanding. This is what you should have on that page in your notebook. This is what I'm going to be looking for to give you that done stamp. What's the definition of a thermal? Where do they form? Where do they not form? Relate that to turbulence. First of all, you got to define what it is, and how do we get it based on what we just talked about. The dust devil you should have sketched when I went through that video presentation. But you got to understand, why don't we have them in Georgia? And conversely, where would you find them? Now let's talk about a downburst or a microburst. When it rains, got this cloud up here, and it's dropping rain. And you can see the rain coming down out of the clouds. We don't see that as much here in Georgia because we don't have the wide open spaces. You know, we're too close to too many trees. We can't see the horizon very well. But what's happened here is as all that rain started to fall, think about all the air that was under the cloud. Well, as the rain falls, the water falling from the cloud pushes on the air and pushes the air down. That's wind. Remember, because wind is the movement of air. So when all of this rain all comes down at one time, it pushes all of the air down ahead of it. And that's what wind is. That's a downburst or microburst. A downburst or microburst is a downward movement of air from rain falling in a thunderstorm. Once again, listen to that carefully. A downburst is the downward movement of air or a downward wind from the rain falling out of a thunderstorm. Now, one thing about this air, and I show this on this diagram here, so the rain hits the ground, but then it doesn't go into the ground, it kind of spreads out. Now this is kind of higher pressure over here because all of that air is being squeezed in here together as the rain is falling, so the air gets pushed out this way. Well, in this spot right here, it's actually a little bit lower pressure because the air there isn't being squeezed together by the rain. So when the air comes out of a thunderstorm, it tends to move up there because it's a little bit lower pressure. And downbursts, microbursts have this kind of little hook shape to them. The air doesn't just move straight across the ground, it kind of curls up. If you've ever been outside during a thunderstorm, and that's a rhetorical question because I know you have, you live here in Georgia, I want you to think about a really bad thunderstorm. Right when it's at its worst, or certainly right before it gets started, isn't it always pretty windy? Think about it. Now, I'm not talking about an all-day rain. I'm talking about like a thunderstorm, like thunder and lightning, violent kind of thunderstorm. If you'll think about it, if you're close to one of those, when it's all coming down, it is windy. That's an example of a downburst or a microburst. Let's sketch that. We'll draw ourselves a little cloud here, and what we're going to do is we're just going to draw like this. That is my air that is getting pushed down to the ground and then goes out and curls up. Once again, the definition of a downburst is the downward movement of air caused by rain falling out of a thunderstorm. So we got the rain pushes the air down, which hits the ground and then spreads out and curls up. Now these downbursts and microbursts can actually be really bad news sometimes. In 2009, a downburst hit the Dallas Cowboys indoor practice facility. And they were actually in the practice facility. 12 people were hospitalized. I remember at least one very seriously. Now this isn't like a permanent building. It's kind of like almost like a fabric colored tent. But the downburst was so severe that you can see what it did. It crushed all the metal framework of this building. Generally, like your house wouldn't be a problem, especially too because your houses tend to have pitched roofs, so that when the air hits it as a downburst, it'll kind of slide right off. But if you had a flat roof, like this training facility did, the wind can push down on it and cause it to collapse. Where downbursts are exceptionally dangerous and have caused lots of problems are flying airplanes. And I'm going to sketch this on here well, first of all, we got our plane over here, and you can see our pilot. He's lining up to land at the end of the runway. He's got his sight, and he's got the plane right on target to land at the end of the runway. But right before he gets to the airport, let's say there's a thunderstorm. There's a downburst. And the air does like this. Well, the pilot's flying along, and all of a sudden he gets right here. And there's a little bit of air that pushes the plane up. So the plane winds up too high. Plane winds up here. And the pilot says, oh crap, now I'm too high. And I'm going to point the plane down low. So he readjusts and he points the plane a little bit lower, so he winds up back on target. But then a few seconds later, he gets to this spot here. Remember, he's got the plane pointed down, and now he's right in the downburst. He's right in that downburst, and that pushes on the top of the plane and causes it to go straight into the ground. And it's hard to recover from because the plane was already aimed down. So downbursts and microbursts are the reasons why planes do not take off and land during severe thunderstorms, because these winds are unpredictable. They're blowing up and they're blowing down, and it makes it hard to land and take off. And there's been scores of airplane crashes that have been caused by these downbursts and microbursts. That leads to another vocabulary term that's associated with microbursts and downbursts, and that's this idea of wind shear. Wind shear is any sudden change in direction of wind. And we see that from a downburst and microburst. The wind's going this way, well then the wind's going that way, the wind's going down. So as the plane is flying through this, you get winds going all kinds of different directions. That's called wind shear. And that's what has made countless planes crash over the years. Most famously, Delta Flight 191 in Dallas, Texas, I think in 1971. This plane crashed in a field before the runway because it got caught in wind shear and the wind pushed the plane into the ground. More recently, this was a FedEx plane crashed in Tokyo for the same reasons. It was attempting to land during a violent thunderstorm, and the wind shear caused the pilot to hit the ground too hard. The plane burst into flames. Pilot and co-pilot were killed in this. Now, mountain and valley breezes, a little bit different type of small-scale wind.
Okay, so we're going to take a look at another example of some small-scale or localized, in kind of one specific place type of movement of air. These are going to be called mountain or / valley breezes. So what we need to diagram here is we need some mountains and some valleys. It's fairly simple. we're going to draw a couple mountains. Something as simple as this. And we've got a valley in the middle, and we've got two mountains. Well, what happens is the sun comes out. Here's our sun, our happy little sun, providing a bunch of energy to our air molecules. Well, where is the air at? We know that most of the air, or there is certainly more air, down low because gravity works. But what happens is the sun gives energy to those air molecules, and now they can move more. They can move more freely. They get energized, and they can expand, because we know hot things get bigger. They expand. Well, in this particular situation, they've only got one place to go. They can only go up, because the mountains are in the way. We can't expand this way and that way. We can only expand up. And that's exactly what happens. This air gets enough energy that it then expands up the mountains. So if you were standing right there, you would feel the air moving past you. You would feel wind. And you would feel the wind going up the mountain, because that's the way the air is expanding when it's getting hot from the sunlight. So what we have here is called a mountain breeze, because it is going up the mountain. Now what's going on here? Let's summarize. First of all, the air in the valley gets hot. Hot air then expands and pushes up the mountain. That's what a mountain breeze is. It's the air in the valley gets hot with the sunlight, and then it moves up the mountain, and that's what you would actually feel. Now, something different is going to happen when the sun goes down. So let's take a look at that. We'll slide this up, and we'll draw the same valley and mountain, but now we'll make it nighttime. Here's the moon and the stars are out. It's now nighttime, and the sun is not able to provide energy to those air molecules, so they're not as able to move around. We know where the air is. The air has all moved up here more, but now it slows down some. It's a little tired. And just like warm things expand, cold things contract. And this air starts to contract and squeeze together, and it gets heavy. And then gravity works. Gravity will pull heavy things back down. And the air winds up back down here. If you were standing on the mountainside at night, you're going to feel that air moving down here. That is what we call a valley breeze, because the air is moving towards the valley. This happens at night. What's going on? That air that was up high gets cold because there's no more sunlight at night, and it contracts, or it squeezes together, becomes heavy. Well, then when it's heavier and more compact and more dense, it sinks. Gravity pulls air back into the valley, and hence we have what's called a valley breeze. So we get mountain breezes during the daytime, and then we turn right around and we get valley breezes at night.
All right, so your final check for understanding. At this point, you should have this in your notes. What is a downburst microburst, and what weather event is associated with it? And yeah, you should sketch that little diagram of how it happens, and the shape or that pattern that the wind takes from a microburst. Now, what activity was mentioned here that was really super dangerous that you really don't want to do during a downburst and microburst? Define what wind shear is. And finally, you should have that description of mountain and valley breezes. Here's an extension question for you. I want you to think about this. This is what's called a snow devil. Take a look at these pictures, and I want you to think about, what do you think could cause this? So that's the end of the presentation. Now you are ready to take the notes check over all of this information.